Let's take a quick look at absolute value equations, and if we have time in this video, let's also look at inequalities involving absolute value. Absolute value, as you recall from our previous discussions, means the distance from zero. So if I have the absolute value of a number, say 8, that means if I have 0 here, then I would need to go 1, 2, 3, 6, 7, 8. Could have picked a smaller number, I guess. That means that from 0, the number 8 is 8 units away. It's a measurement. It's a distance. At the same time, the number -8, if I were to take the absolute value of that, well, that is 1, 2, 4, 5, 6, 7, -8. So if 8 here is 8 units away from 0, the -8 here is also 8 units of 0. So the absolute value, so this is equal to 8, and this is also equal to 8. The absolute value of any number is equal to the absolute value of the opposite of that number. And notice that in both instances, my absolute value is 8, because the absolute value is the distance from 0, and any distance is always positive. So let's see what happens if we have an expression with an absolute value. So here we have the absolute value of the quantity t minus 7. If I take the absolute value of that and subtract 5, set that equal to 4, here's what happens. We have to treat the absolute value like a grouping symbol, much like if it were parentheses. And so in order to deal with that, if I had a number times the parentheses, then I'd have to move this over first or distribute the number in, whatever. So let's start by moving what's outside of the absolute value. We can say that an absolute value of one number is just like a variable, right? This would be the same thing as saying y minus 5 is equal to 4. And so to solve for y, I have to add 5 to both sides and see what happens, right? Well, let's do that here. Let's add 5 to both sides. Those will cancel here, and I'm going to be just left with the absolute value of t minus 7 equal to 4 plus 5 is 9. So first of all, we have to ask, is it valid? And in order to answer that, we need to know that an absolute value, as stated up here, has to be a positive number. So what we've got is, yes, we do have a valid absolute value equation, because 9 is in fact positive. So as in above, we saw that the absolute value could be of a positive number is positive. The absolute value of a negative number is also positive. So we have to say that, well, if t minus 7, the absolute value of it is 9, then that means that t minus 7 is either equal to 9 or t minus 7 is equal to negative 9. And if t minus 7 were 9, that means that t would be 16. And if it were negative 9, well, that means that t would be negative 2. So on a number line, in order to make this sentence appear true, t would either have to be negative 2 or 16. It would be one of these two numbers. And how would we write that as a solution? So the solution set would be, we usually put solution sets in the squiggly braces. It would be negative 2, 16. That would be our solution set. Now let's try an inequality with an absolute value. Let's say that 2x minus 1 over 3 is less than or equal to, we'll say 1. Okay, so this says something a little bit different than what we've got here. Remember that an absolute value can be a negative number or a positive number. So if the absolute value of 2x minus 1 over 3 is less than 1, that means that whatever's inside that absolute value symbol is greater than or equal to negative 1. So let's say 2x minus 1 over 3 is greater than or equal to negative 1, but less than or equal to 1. Mind you, on a number line, anything with an absolute value of less than or equal to 1 is going to be all in this section right here, right? And that's what we're trying to find. How would I make this expression fall into here? How does this go into that space? So let's work backwards and start by multiplying all sides of the equation by 3. 3 times negative 1 is negative 3, is less than or equal to, cancel, cancel, 2x minus 1, less than or equal to, 3 times 1 is 3. Now we can add 1 to all sides of the equation to maintain our balance. And so we get negative 3 is plus 1 is a negative 2, is less than or equal to 2x, cancel, cancel, which is less than or equal to 3 plus 1 is 4. Now we will divide by 2 all sides of the equation, and we get cancel, cancel, negative 1 is less than or equal to x, which is less than or equal to 2. So there is our interval. On a number line, the solution set would go from negative 1, it would include it, all the way to 2, including that. Let's do that in a different color. Here is our solution set. It would be everything in between here. Using interval notation, it would be negative 1 all the way to 2, and it would include both of those.